All right. In this video, I'm going to walk you through the density lab because it uses Flash, and so not everyone might be able um, to utilize it. I know there are some issues, so I just want to kind of go through this with you. So um, and the first question asks, what is the density of wood? So we have it set to wood right here. And there's a couple different ways to do that. Now, one, it just shows you right here, zero point 0.4. But the other thing you can do is actually go ahead and divide um, 2.53. This is what it's set at the moment. 2.53 by 6.32. Just divide this number by this number, and you get zero point 0.4. Again, right to that. So that's where you would, for that first number one, you just write 0.4. Next, it says when you move the slider for mass to increase it, what happens to the volume? So we go ahead and grab this slider and I move it, and we'll note that the volume increases as well, right? You can see, right, the block actually getting bigger. And the question, right, maybe why is that happening? Um, is because if you think about it, right, this number zero point 0.4 can't change. So, you can't change the density of your piece of wood. So if you want to get a heavier piece of wood, you actually have to go get a physically larger piece of wood. And so that's what's going on here, right? Because you can't change the density of wood, like if you want a heavier piece of wood, you just go get a bigger piece of wood. So that's what's going on there. The density of water is 1 gram per milliliter. Why does wood float? Well, if we look at the density of wood, it's zero point 0.4. So if we think about whether something's going to float or not float, we have to compare those densities. Is it more or less than the density of water? If it's less than the density of water, it's going to float. If it's more than the density of water, it's going to sink. So zero point 0.4, since zero point 0.4 is less than 1, it will float. And the next thing I'm supposed to do is change to styrofoam, but so styrofoam has a density of 0.15, and I need to predict, will it float on the water? Well, let's think back to what we just talked about in number 4, and let's think about whether that styrofoam will float. So the density is 0.15. Is that going to float or not? So what I'm going to do, you should pause the video right now, right? Answer questions 1 and 2. Number 2 asks, will the styrofoam cube float higher or lower in the water than the wood? So here, right, we can see this piece of this wood right here is, maybe a third underwater. Do you think that's going to be true for the styrofoam? So go ahead, pause, answer number 1 and number 2, and then we'll come back. All right, at this point, you should have done that. You should have answered question 1 and 2. So now let's go ahead and bring up styrofoam, see what we did. So there we see that it does indeed, right, it floats higher. So it does float because it's less than the 0.15 is less than 1. And not only that, it floats higher in the water because um, it's even less dense than wood, right? So that's going to push it even higher up. So since that difference between the density of water and the density of styrofoam is even greater, it's going to want to float more. So now we want to switch to brick. So I'm going to pull my here we go, brick. Okay, and that sinks. Why do you think a brick would sink? So let's note that its density right here is 2. Um, so right for number 1 under the brick, think about, why does the brick sink? Uh, Remember, we've kind of decided that if it is more dense than water, then it is going to sink, and if it's less dense than water, it's going to float. So now I'm going to switch to aluminum density, or to aluminum. Okay, so its density is 2.7. And now switch back to the brick. Imagine we melted a bunch of aluminum, so we had a pool of aluminum instead of water. If we drop the brick in, would it sink or float? Okay, so aluminum has a density of 0.7. So, and a brick has a density of 2, right? So again, our rule for does it float is if the density of the thing that's floating is less than the density of the water, or in this case, the aluminum, then it'll float, right? Um, so we should see that, right, a brick, which is 2 kilograms, is is less dense than aluminum, so that brick should float in the aluminum. So I don't think we can actually try that one. So now change the blocks on the right to mystery. So we want to switch them to mystery here. Okay. And your goal is to calculate the density of each block. So let's see here. Things to notice. There are 5 multicolored blocks. You can drag the blocks and place them on the scale on the left to get the mass. So you can take E and put it there. You can put them in the water to see if they float. So that's going to tell you whether they're greater than or less than 1. You can find the volume by dropping the blocks in the water and seeing how much the volume increases by. So note that right now the water is 1 liter. So let's do these in order. Can I grab A? Okay, so let's start with A. So we'll just do these in order. So the mass of A is 65.1 or 65.14 kilograms. Okay, so make sure you write that down. We'll take that and we'll put it in the water. First up, we know that it doesn't float, so the water went from 100 to 103.38. So that means that the volume of 1 is 3.38 liters, right? Because we just need to know how much it went up by. It went up by 103.38, or sorry, it went up by 3.38. So just write down 3.38 for that. Okay, so next we'll do B. So we'll get the mass of B, put it over there. Mass of B, or mass of, sorry, yeah, mass of B um, is 0.64. Oh, sorry. And then we'll take B, we'll put it in the water. And right, it is now 101 liters. That means it was a 1 liter cube. So the volume of B was 1 liter. Right, you gotta pull it underneath to see the whole amount there. Alrighty. Now again, to get the density of those two things, you're going to divide them. So I'll take C. Mass of C is 4.08 kilograms, and the volume of C is 5.83. Again, you guys subtract 100 because you just want to see how much it increased. So it went from 100 to 105.83. So that is a difference of 5.83. So your volume is 5.83 liters. Okay, you would then divide those two numbers to get the volume. Okay, mass divided by volume. So we'll put them over here. Next up, D. Oh, that one went in the water. We can't have that. Okay, so D has a mass of 3.1 and a volume of 3.38. So, right, 3.38. And then lastly, E, mass of E is 3.53. And it has a volume of 1. So again, you're going to go through and for each of those numbers that we just figured out, you're going to divide them, the mass divided by the volume. That will tell you the density of each one of those. You're going to need to show your work in the on your little sheet there. And that should basically help you complete the density lab. All right, thanks for watching.